for this certain differential equation is shown above. Which of the following could be the solution for the differential equation with the initial condition as being y of 0 is 1? So that means the initial condition is when x is 0, the y coordinate has to be 1. So which means all these things, so 0, 1, so it would be something, yeah. So this is what is the initial condition is. Okay, so now we have to back solve the sum. So can it be cos x? So that is the first thing that we need to think about. So if I talk about the graph, how does the graph would look like? See, if you look at it from the graph, so whenever I have, let's say if the curve is like this, my tangents drawn at a various point for this curve would look something like this. So in that case, the vice versa is also true. If just the tangents are given, and we can also think about drawing the curve, and the curve would look something like this. So keeping that in mind, so we clearly know this, the gradient at this particular point, which is gradient at x equals to 0 and y equals to 1, is just 0 itself. So now we need to figure out, so which of these functions can give us the gradient at 0 at these particular point? If I talk about differentiating, let's say e power x. So y dash, which is y dash is the derivative of e power x. So e power x is going to be e power x itself. And when we put x as 0, so we will be getting e power 0, the derivative is going to be 1 itself. So which means when x is 0, so we are getting the first derivative, the gradient of a tangent to be 1. So that's why C cannot be my answer. So next, if I talk about this particular point, so which is y equals to square root of 1 minus x squared. So if I find the derivative of that one, so y dash is equals to 1 over 2 into square root of 1 minus x squared into the inner function, it's going to be 2x minus 1. So if I substitute x as 0 here, so we will not get 0 again. So that's why we can easily eliminate C and D. Yes, of course, in A and B, so we will be getting 0 itself. So this is for option C and this is for option D. Now, if I talk about option A, how does this option A would look like? So the derivative, which is y dash, would be equals to sine x. So in that case, when x is 0, so it's going to be sine of 0. So which is nothing but sine of 0 is going to be 0 itself. Yes, that's true. So when x is 0, so throughout this one has to be 0. But when x is, let's say, pi by 2. So when I say pi by 2, so that means something like 1.57 something. So when x is pi by 2, so it's going to remain constant, which is my sine of pi by 2. So sine pi by 2 would be always equals to just 1. So now when x is something like 1.5, so the gradient of the tangent has to be something around 1, and the 1 would, and positive 1 would, should look something like this. But these tangents doesn't look like a positive 1. So that's why I can also easily eliminate option A. Now, if I talk about option B, so the y dash has to be equals to just minus 2x. So in that case, when x is 1, no matter what is the value of y is, so whenever we have x as 1, so we should always get the gradient to be minus 2. So when x is 1, the gradient has to be same throughout. And that's also not happening here. So that is the reason it cannot be option B as well. So that's why the right answer for the sum has to be option E. So how we can say option A is? So the option E goes something like this. Let's say I have y equals to this. If I find the derivative using the quotient rule, so y dash is equals to differentiation of numerator, it's going to be 0 and keeping the denominator as it is. plus, or sorry, it would be minus differentiation of denominator, which is going to be just 2x, and keeping the numerator as it is, and entire thing divided by 1 plus x squared. So here, if I simplify this one, so this thing can also be written as 1 plus x squared whole square. So this thing is going to be minus 2x over 1 plus x squared whole square. So if I want to write this denominator in terms of y, we know this 1 plus x squared whole square is just going to be 1 over y. So 1 plus x squared, when I make 1 plus x squared the subject, it's going to be just 1 over y. So when we substitute 1 over y, it's going to be minus 2xy. So which means this would suit. So when x is 0, it's going to be 0 always. When x is 1, but y is 0, it's going to be 0. Yes. When x is 1, y is 1, it's going to be negative 2. Yes, it's a negative. The tangent has negative gradient. If you look at any point, it would be the same thing. So that's why E is the right answer.